In this lesson, we are looking into transforming graphs. We will learn how to recognize and apply various transformations on graphs based on their functions. In total, there are 6 transformations, but actually it's just 3 groups of 2. Yep. So we'll have a look into them one by one. Now, first of all, in total, there are 3 transformations, as I've said. First one is called translation, and then a stretch, and then a reflection. Okay, each of them has a X version and a Y version. Right, so let's look at the first one. Now, in terms of translation, it's all about adding and subtracting the A, inside and outside. If you're adding a number inside bracket, your translation horizontally. If the A is outside, then you're translating vertically, so you're moving up and down. Now, it depends on the value of A. If it's a positive value of A, you move to left. If it's negative A, you move to right. So anything left and right deals with the X coordinate, so horizontally. Plus A on the outside means if it's plus A, you move up. Minus A, negative A, you move down by the value of A. There are some examples in here. For example, if you have a f of x equals x squared, if you have f of x plus 2, then the function becomes x plus 2 squared. However, if the plus 2 is outside, you can see the function is different, x squared plus 2. We'll talk about this in similar concept as composite function, I guess. Now, if it's times a times x rather than add and subtract, then this will call a stretch. Okay, a stretch. Inside bracket, you're stretching horizontally. Scale factor 1 over a. If it's a outside, you're stretching vertically. Scale factor 2 times a. So do take note. If it's inside bracket, it's 1 over a. If it's outside, it's just a. Next one, a reflection. Now, negative x, if a negative inside bracket, you're reflecting in a y-axis. Now, it might sound a bit confusing, but anything inside bracket, it does affect the x coordinates. So when you do reflection, you will have to reflect in the y-axis so that the x coordinates are affected. If you reflect in x-axis, let's say that point there, if you reflect, let's say I just call it that point 36. If I reflect in the x-axis, so x-axis is my reflection line here, okay, that's my reflection line. If I reflect along that line, then my point will be here, which is 3, negative 6. Now, what you do realize is when you reflect in x-axis, the y coordinates changes. So that's why it's quite important to remember, rather than remembering which axis you're reflecting on, you remember what coordinates is affecting, because this will be in line with the translation and the stretch. So here I'll give you the super duper quick notes. If the thing is inside a bracket, whether it's plus a or a times or negative, you're affecting the x coordinates. And remember, x is rebellious. It's like a spoiled kid. It will do things oppositely.
I want candy! I want candy! I want candy!
Emotional, damn it!
A plus a means you move negatively. So negative, so move left to negative x-axis, you move left. Ax times it by 1 over a. Scale factor is 1 over a. For example, in here, f of half x means you are stretching 1 over half is the same as 2. So that will be the same as stretching horizontally by 2. Just give this is the scale factor 2. We'll talk about that in a bit more details later in examples. F of negative x, if you have minus x, then you're reflecting in the y-axis, because if you reflect in y-axis, so that's the x point. If you reflect along on the y-axis, that point is minus 3, 6. So you can see the x coordinate changes. That's how I remember it. Okay, so x is a spoiled kid. Next one, if it's outside bracket, they affect the y coordinates. Okay. First example. First of all, we have to sketch a graph of y equals x squared, and we'll see how does the effect of each of them affect the transformation. Okay. So first of all, sketch a graph of y equals x squared. Now you must know that this is a grade 8 topic, so you must know some basic graphs like x squared graph. So x squared graph looks like this. Using my masterpiece, master art drawing skills. This is a very nice parabola, x squared. So y equals x squared. Second one, part B. Now y equals x squared minus 3. Now let me tell you, B, C, and D, they're all building up from A. Okay, so we call A the parent function. Now you don't really have to know this until A level, really, parent function, but you will cover a bit more in details later. This is called parent function. That means the original, the OG. So x squared minus 3. Now you can see the minus 3 is on the outside of x squared. So I have put in the list of transformations for you in here. Now you can see minus 3 on the outside is similar to this one. This one, because the minus 3 is outside, is plus and minus, so it's definitely a translation. The minus 3 is outside, the fact that means is affecting it on the y coordinates. So minus 3 means negative a, so moving the graph down. So move, basically, part B means move graph down. Oh, actually, we shouldn't use the word move. We should say the word translate by 0 minus 3. Okay. So how does the graph look? Well, it's a sketch. Sketch means it doesn't have to be in scale. So move down by 3, it means we're touching the origin in here. Now we'll be touching the y-intercept will be minus 3, and that's the answer. Okay, part C. Y equals negative x squared. Now, where is the negative? Is the negative inside or outside? Well, this is outside. If it's inside, it will become minus x squared like this, which is same as x squared. So the minus doesn't do anything. Anyway, so if the minus inside, it will be like this. So therefore, part C, the negative is on the outside. If the negative is on the outside, this is the one they're talking about. So reflection in the x-axis. So we're going to do reflection in the x-axis. So reflection in the x-axis, that means this x-axis, so reflecting it. So that like that, x, y. We're reflecting the original. Okay. Part D, x minus 4 squared. Now this time a plus and minus. So first thing comes to your mind is about translation. Okay, translation. So what's translation? And inside bracket. So inside bracket means affecting x. So translation. Okay, graph inside the x. Now x rebellious. Minus 4 means you move graph by 4, 0. So move to graph to the right by 4. So original is here. Move to right by 4 means like this, 4, and that's the answer. Practice question 1. Here is a sketch of the y equals f of x, where is x plus 1 squared. So you're given the graph of x plus 1 squared. Okay, you have to sketch a graph of f of x plus 1. So use the notes in here, the 6 transformations, to help you to determine which one are we moving, how we're moving, and try to sketch a graph of it. Note, you do not have to work out the function itself. That means you do not have to work out the new algebraic function. You just have to apply the transformation and move the graph accordingly. Okay, pause the video. When you're ready for the answer, you can press play. Here are the answers. So I did write out the actual transformation for you. In the exam, when they ask you to sketch a graph, you don't really have to write down what transformation is it, but it's just for understanding what I've done. A, I've moved up the graph by 1. Part B, I've moved the graph right by 2. Part C, reflection in the y-axis, reflection in the x-axis. Part D. Next example, we also need to learn how to transform trigonometry graphs. Now this will prove quite challenging for some students because, well, not only you have to know all the transformations, the 6 transformations we'll talk about, but also you need to remember the graphs of sine, cosine, and tangent graph. Okay, so it might prove a bit challenging, but if you forgot them, make sure you go back to the video and look at the one about the trigonometry graphs. Okay, right, so example A, sketch a graph of f of x equal cos x, where x is between 0 and 360 degrees. So first of all, we draw a pair of axes. Next, now if you don't remember what it is, you can remember it by the special values for cos or cosine. Cos 0 is 1, so that means we know when x is 0 degree, we start from 1. And if you remember cosine, it has a range of values between -1 to 1. So that means 1 is the highest point. So we start from here. And then cosine 90 is 0. So cosine 90 is 0. So that means we come down and we go more negative and we come back up and finish the cycle. So that's 360 degrees. So that point is 360 degrees. This is 270 degrees, 180 degrees, 90 degree, and 0 degree. Okay, and that's the y, and that's the x. So that's part A. Okay, I must admit this is one of the nicest and one of my best drawing of cosine graph. It's a treat for you. Right, part B. Sketch a graph of f of x minus 30 degree. So x minus 30 degree. So x minus 30 degree, f of x minus 30 degree. Inside the bracket, plus and minus means we're moving it. So translation, okay? So we're moving the graph to the right because inside bracket is about x. X is rebellious, we do the opposite. So minus 30 means plus 30. Plus 30 means move to the positive right by 30 degree. So all these values that you see in here, we're going to move to the right by 30 degree. Okay, so now move to right by 30 degree. Now, the previous graph is like this. If I make a bit of graph, that means we're going to move to right by 30 degrees. So the graph will look like this. Right? This will be 120 degree. This point where it was 180 becomes 210 degree. Sorry about my mouse, it's a bit annoying. And this value will be 300 and, well, actually we should, yeah, 300 degree. So actually we should move to right. And this value will be 290 degree. Okay. Part C. Sketch a graph of f of x plus 2. F of x plus 2. Maybe you can tell me what it is. What transformation is this? Plus outside. So plus means translation. Outside means vertical. Vertical 2. So move up by 2. Oh, by the way, that's actually didn't finish it. The bottom should be -1. That point is 1. That highest point negative. The lowest point is -1. Move up by 2 means the whole graph moving up by 2. So the 1 move up will become a 3. -1 will becomes a 1. So what does it look like? Well, it just means the graph is now floating on the above the x-axis. So we start from 0 becomes a 2. So if we start from 2, let's say in here, this will become, so we start from 3. Okay, so that's point is 1. That point is 360 degree. That point is 270 degree. That point is 180 degree. That point is 90 degree. And that's the x and that's the y. Right. Now, usually you see these type of questions quite late in the paper because it is quite hard for GCSE content in terms of GCSE content. Question D. Sketch a graph of f of 2x. Okay, so now you might be wondering why was there no 2x before? Because I do want to introduce things bit by bit. So you should be quite familiar with translation and reflection now. So let's dive into the stretch area. F of 2x. So f of 2x. First of all, f of part D. F of 2x. It means multiplying means a stretch. 2 inside means stretching in x direction, okay, or stretching horizontally. X is rebellious. 2 means by half. That means all the x coordinates that you see in the original. So I am I'm multiplying all the x coordinates by half. That means this will becomes 45. This will become 90. This will become 135, and this is 180. So imagine you're pushing in the graph means compressing the graph, like you're clapping hands, but you're pushing in the graph by half. So what it means is we're going to start with the same place. Now this part was 180 degrees, so this is 180 degree. Now if we were to draw the graph into 360, that means we could fit in another cycle. That's 360 degree. Okay, and that's the answer. Well, if you do want to fill in the gaps, this will be 270 degree mark. This will be the 90 degree marks. Okay, right. So stretching horizontally by half means you're multiplying all the x coordinates by half. So where it was 90 becomes 45. So if you're wondering, these are the points that it were there before. 180. Yep. Okay. Right. Question E. Sketch a graph of 3f of x. So 3f of x means we're stretching vertically by y is normal, so 3. So 3f of x times by 3. So we are multiplying all the y coordinates by 3. So the 1 becomes a 3, the -1 becomes -3. Now this 45 degree has nothing to do with it anymore, so we're using the same x values. It's just, imagine you are making pasta. I don't know if you've made pasta before. You are like stretching the dough upwards. So using your hand, stretching the dough upwards and downwards. So let's draw a pair of axes. Means now you can draw it a bit more with a more dramatic effect. But a sketching means you don't have to really show a difference. You just have to show numbers. So now a normal way of drawing is like this. Oops, actually it should be like this. I'm not happy with it. I'm not happy with it.
Bruh.
Yeah, a bit better, but still. 3 and -3. All the numbers remains the same. 90, 180, 270, and 360. But if you do want to show a bit more, you can, I guess you can draw a bit like this, a bit higher and lower, I guess. But you don't really have to, it's just about numbers. Practice question 2. This time it's your turn to perform the transformation on the graph of sin x. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Just practice question 2, the answers. Sorry about squeezing in the middle in here. I would say these, the one probably the hardest one, but you do realize this stretching horizontally by a third means you're pushing everything by 3, so 3 loops. And for part E, stretch vertically by 4, so 4 and -4. In some exam questions, they do not need you to actually sketch a graph, but instead they could test your understanding on transformation of graphs by locating the new transformed coordinates. For example, here's a graph. They did not tell you what graph it is. It doesn't matter. What we know is that point 3, 4, you will have to transform that point, and they ask you for the coordinates of the transformation. So you need to know very well your transformations, the 6 transformations as we said. Part A, f of x plus 2. So hopefully you'll be able to tell me what it is. So plus 2 inside, plus 2 means move. Plus 2 inside means we move left by 2. Or technically translation -2, 0 like this. So it means move the graph to left by 2. So that point 3, 4 will now becomes 1, 4. And that will be our final answer. Part B, a half x, a half f of x. A half on the outside, a half means stretch because times a half outside, so stretch vertically by a half. So that means in terms of coordinates, it means we are multiplying the y coordinates by a half, because stretching vertically means affecting y coordinates. So 3, 4 becomes 3, 2, because 4 times a half is 2. Part C, negative f of x. Negative means reflection. Outside bracket means affecting the y coordinates, therefore reflecting in x-axis. So if it affects the y coordinates, so 3, 4, so becomes 3, -4, because you're reflecting x-axis. Part D, f of 4x, so means again it's this time it's a stretch horizontally, inside bracket, horizontally by a quarter. So stretch horizontally by a quarter means we are multiply x coordinates by a quarter. So 3, 4. Now 4 is not a factor, so 3 times a quarter is 3/4. So because 3 times a quarter is 3/4, so 3/4 4 is the answer. A bit weird, but it is what it is. Here comes the last practice question. This time you've got two coordinates that you need to transform for each transformation. For part for part F, there are two transformations. So do give you a bit of heads up. There are two transformations in here. Just do it one by one. It doesn't matter which one you do first. Okay, right, have a go at the question. When you're ready for the answer, you can press play. So here are the answers for question 3. So part A, you will have to stretch. Outside 4 means stretch in vertically by 4. So all the y coordinates times it by 4. So 2 becomes 8, minus 3 becomes minus 12. Part B, a minus 5 inside bracket means you move to the right by 5. X is rebellious. It's a spoiled kid, so you do the opposite. So you add 5 to all the x coordinates. Minus 1 plus 5 is 4. 4 plus 5 is 9. C, 3x stretch inside bracket, so horizontally by a third. So minus 1 times a third is minus a third. 4 times a third is 4/3. D, minus x. So negative inside brackets means reflection, but affecting the x coordinates. So reflecting in the y-axis, or the x coordinates changes minus 1 to 1, 4 to minus 4. E, f of a half x. A half inside bracket means a stretch again horizontally, but this time by 2. So you multiply all the x coordinates by 2. Minus 1 becomes minus 2. 4 becomes 8. Now for f, the two transformations are plus 2 means we move left by 2, minus means reflect in the x-axis. So it doesn't matter which one you do first in this case. So what I did was I move it first and then reflect. So I move to left by 2, so minus 1 to minus 3, and then reflect in the x-axis means the y coordinates is affected, so 2 becomes minus 2. So my final answer, minus 1 to 2 becomes minus 3 to minus 2. Minus 3 minus 2. And same for 4 minus 3 becomes 2/3. 2/3, sorry.